Alright, so let's say given this question here of you have a guy running up a hill that's 50 meters tall, and the question says a guy runs up a 50-meter hill in 15 seconds. What is his power output to accomplish this? To solve, we need to use the power equation, which is P equals F parallel times V, where F parallel is the force parallel to the displacement, and V is the velocity. The assumption that we have to make in this question is that we're only considering his power to get to a height of 50 meters. So if we look at our diagram, the height of 50 meters is going to be our assumed displacement, but in reality, delta S, this length here, is actually the real displacement, but the question doesn't provide info for this, so we're just going to assume that the height is delta S. Looking at our equation, what will F parallel and V be? So we start by looking at F parallel. So for the guy to get to a height of 50 meters, he must exert an upward force equivalent to the force of gravity. So F parallel equals W, and delta S is going to be 50 meters, and we can see that force is in the same direction as delta S, which is important to note since this is the definition for F parallel. For velocity, the question says he gets up the hill in 15 seconds. So our time's going to be 15 seconds and the distance going to be 15 meters. That's the height of the hill. We can just simply do velocity is equal to distance divided by time, and we can plug in our two values, and then we can compute the amplitudes in the units, and we get this for the velocity. And so we can apply these both to our equations. F parallel is going to be equal to the weight force, which is equal to mass times gravity. So we plug in mass and gravity, compute the amplitudes in the units. We're going to get 98 newtons for the force parallel. We can also plug in our velocity that we found equal to 3.33 meters per second. And we can compute the amplitudes in the units of this expression, remembering that newtons per meter is equal to a joule and a joule per second is equal to a watt. So our units make sense for power. We get this final answer. This is the power output of the person to travel up the hill in 15 seconds. So as this person travels up the hill with a velocity of 3.33 meters per second, he's exerting a power due to this velocity of 327 watts.